Okay, so this is video lesson number 1, Introduction to Acceleration. I apologize, this is not exactly how I imagined this video would look. I had recorded it and my computer froze and I lost the original video. Ideally, I would be writing as I was talking, so I'm actually going to have you try to ignore what you see below. And so to do that, I'm actually going to use this little white box to help you focus on what's important. So, first up, the idea that acceleration is the rate of change in velocity. So we see that acceleration is the change in v2 minus v1 divided by t. v1 is the initial velocity. So that's the velocity at the start of an interval of time. And final velocity is what the velocity ends up being at the end of that interval of time. And time is how long it takes for this change to have. We've talked about a lot of rates this year. Actually, not a lot. We've talked about a couple others. Most notably, we talked a lot about velocity. Velocity is a very similar equation. It's distance divided by time. It's how far the distance is, how much the distance has changed. In this case, we're looking at how much the velocity has changed. The units are kind of ugly. So look inside this box here. The units are typically meters per second per second. And so right now, I'm talking about this area right here. Meters per second per second. Meters per second in the numerator, that comes from the fact that velocity is measured in meters per second. And then when you divide by time, you get that second, the additional second in the denominator. Meters per second is really the same as saying meters per second divided by seconds. Right? When you divide by a number, that's actually the same as multiplying by the reciprocal. So this all becomes meters per second times 1 over second, which ultimately you can reduce to meters per second squared. It is fine to see this in this unit either in this format or this format. Either will work. They mean the same thing. So sliding down a little bit more here, I've given you a strand of common meters per units for acceleration. Meters per second squared, kilometers per hour squared. Then you get into these next two that are mixed units. And they're mixed because the time value, you'll notice, is in two different values. We have hours and seconds. And normally, we say that's not okay. Right? I always am stressing trying to get the units into the same unit, get quantities into the same unit. But it's actually okay in this case to have kilometers per hour per second, which reduces to kilometers divided by hours per second. And the same is true for miles per hour per second. Notice in all of these, they have one distance unit and two time units. Okay, here's a quick example. In the United States, we typically have cars are advertised based on their acceleration. They're typically, for instance, sports cars, people will tell you how fast they can go from 0 to 60. And I think the going rate is about 0 to 60 in 2.7 seconds. I made the numbers a little easier. We have a car that goes from 0 to 60 in 3 seconds. The initial velocity, v1, is 0 miles per hour. The ending velocity, v2, is 60 miles per hour. Time is 3 seconds. And so when I go plug in the numbers, I'm going to do 60 minus 0 divided by 30. That gets you 60 over 3. The units are miles per hour per second. and you can reduce that to 20 miles per hour times seconds. Conceptually, what this means is that for every second the car accelerates, the car will gain 20 miles per hour of velocity. So if you were in the car watching the speedometer, every second you would expect it to register 20 miles per hour more. So in 1 second it would go to 0 to 20, and the next second it would go 20 to 40, in the third second it would go from 40 to 60 miles per hour. So here's a practice problem. I want you to hit pause and go ahead and try and solve that practice problem, then come back and check your work. Okay, so you're done. We know V1 is 0, V2 is 96 kilometers per hour, and the time is 3 seconds. Plug in those numbers, 96 minus 0 divided by 3. That'll get you 32 kilometers per hour per second. And you'll see I reduced that to 32 kilometers per hour times seconds just by playing with the fraction. Moving ahead, acceleration can be negative, and that's because we're taking a difference. So if V1 is a bigger number than V2, the acceleration will be negative. And typically that means the object is slowing down. It doesn't actually have to always be that way, but that's the most straightforward case. So to illustrate this, I have a second practice problem. Again, I want you to hit pause, work this out, and then come back and check your work. So you're going to calculate the acceleration of a Dana minibus that is traveling at 25 meters per second and slows down to 20 meters per second in 2 seconds. So do that, come back. Okay, you're back. V1 in this case is 25 and V2 is 20. Notice V2 is a smaller number. That's because the minibus is slowing down. And it takes 2 seconds for the car to slow down, or the bus to slow down. So when I plug in the numbers, I end up with 20 meters per second minus 25 meters per second divided by 2 seconds. And that leads us to 5 meters per second negative. It's a negative change in velocity because we're slowing down. Divided by 2 seconds for an overall negative 2.5 meters per second squared. So this is the end of video 1.